Hey everybody, welcome to lecture 8. So in this lecture we're going to be learning how to use or using arrays and scalars. Okay, so first off we're just going to import numpy as np, and then something we can do is say let's check 5 divided by 2. So in Python version 2, if you were to input this command, 5 divided by 2, notice you'll just get a whole integer there. You're not going to get 2.5 as it should be. If you declare 5 to be a floating point by saying 5.0, and we run this again, Alt Enter, then we do get the true answer. It treats that as a floating point. In order to take care of that, we can import from the future. I know it sounds crazy, but we can totally do it. So we can say from __ future __. We can import division. So if you're running on Python 3 point whatever x, you won't have to worry about this. It's already going to be standard. But if you're running on Python 2, you're going to have to import from the division from the future to take care of that problem. So now let's go ahead and see 5 divided by 2, and we get 2.5. Excellent. Alright, so let's go ahead and create an array. Like we've done in the last lecture, we can say we're going to call this array arr1, and I'm going to say np.array. And like we learned in the last lecture, we can do it with a list of multiple lists. So I'm going to do just that. I'm going to say 1, 2, 3, 4. That's be the first list that I input, and then the second list that I input will be 8, 9, 10, 11. Okay, so now we got that. Let's go ahead and see what that multidimensional array looks like. So we have a 2 by 4 here. Excellent. So what can we do with that? We can try multiplying arrays. So in this case we can say array1 times array1 times array1, excuse me. So what do we get here? So if you do this kind of command, it's going to multiply every value in the same spot of one array by the value of the other one in the same spot. So for instance, 1 times 1 is 1, 2 times 2 is 4, 9 times 9 is 81, etc., etc. So you can do some scalar operations there in a sense. You can also do subtraction. So we can say array1 minus r1, there we go. And you'll get a 0, which makes sense because 1 minus 1, 2 minus 2, etc., etc. And then you can do arithmetic operations with scalars on the array. So for instance, if I wanted to say 1 divided by every value in that array, this would be the same thing as saying every value in the array to the power of -1, so creating it as the reciprocal of a fraction. There we go. And that's what we got. So if we look at the original array, 1 divided by 1 should be 1. And then we say 1 divided by 2 should be 0.5, and if we look at some other values here, 1 divided by 10 should be 0.1, so that makes sense, the same as 1 over 10. So you can do that as well. And then lastly, you can also do exponential operations. So you could say that array to the power of 3, so every element in that array to the power of 3. And that's what you get. So 1 to the power of 3 is just 1, 2 to the power of 3 is 8, etc., etc. So that's how you can do some mathematical operations on arrays and also arithmetic operations using scalars. Okay, so we'll be using these throughout the course. Go ahead and do an overview, make sure you understand it. And otherwise, I will see you in lecture 9. See you there.